In this video, we'll go over the answer key for our magnesium chloride antitransporter from test 4. Now, everybody will probably have had different numbers than what I have up here, but the way to solve this problem, it's the same. So just plug in whatever numbers you had to what I have here to figure out how to solve this. All right, so it's an antitransporter, and this pumps magnesium outside the cell. If it's an antitransporter, that means chlorine goes inside the cell. I'll pump 2 magnesiums for every 3 chlorine. Concentration inside the cell is 0.3 millimolar, outside 0.45. Cl inside is 0.350, outside is 0.225. We are pumping S37C, and the inside has a positive charge of 0.05. Now, I highly recommend you draw a picture that has all of these numbers written down and shows you which direction the magnesium and the chlorides are going. That will help out a lot. So the equation that we're using is this. Free energy of transfer equals RT natural log concentration final destination divided by concentration initial destination ZF delta membrane potential. All right, so let's see how we do this for magnesium. First off, I'm going to multiply this whole equation by 2 because we are pumping 2 magnesiums. So gas constant 8.314 times the temperature in Kelvin, which is 315, times the natural log of 0.450. All right, so let's take a look at this. I'm pumping magnesium outside the cell. Outside, my concentration is 0.450, so final is 0.450, divided by initial, which is 0.3, that's where I started out from. So that's my first term, plus Z. Z is the charge of our ion, or Za. So our ion is magnesium, which has a +2 charge, multiplied by Faraday's constant times negative 0.05. All right, so where's this negative comes from? So I'm inside the cell. The inside the cell has a charge of positive 0.05, and the outside we're going to assume is 0. So I'm going, if I do final minus initial, that's how you should calculate this delta. Anytime you see a delta, it means final minus initial. So my final charge is 0 for the outside the cell, minus my initial charge of 0.05, that's where I get this negative 0.05 from, and my energy is negative 18,374 joules. Alright, do the same thing for chlorine, except multiplied by 3 because I have 3 chlorine molecules. So my final 0.350, that's because I'm transporting Ca inside the cell. Initially it was 0.225. Negative 1 because chlorine has a negative 1 charge. Faraday, and 0.05 for our membrane potential because we're transporting inside the cell. You get negative 12,965. What's the overall free energy? Add these two together. Negative 31,339. Anything with a delta G that's negative is spontaneous, so this is a spontaneous reaction. If you have other questions about the test, please let me know. Otherwise, good luck on the final.